So guys, welcome to Tech Motivator. This is your host Anand Trivedi. Guys, if you haven't watched the other parts of the series, this is the 5th video of the series. So I kindly recommend you that kindly watch all of the previous 4 videos. Now this video is concerned with introduction to basics of the data science. That is actually we are going to know the terminology that we will be using for the data science, right? So let's actually see what are the different categories involved and all those stuff. Now, machine learning algorithms are basically divided into 3 broad categories. They are reinforcement learning, supervised learning, unsupervised learning. Well, do not worry about it. I am going to discuss about them in this series. In this video. So, supervised learning, unsupervised learning and reinforcement learning. You just need to, this is just the agenda that we are going to cover. Now, supervised learning are further into 2 types, classification and regression, right? And unsupervised learning is into clustering. So let's break this down, what this is. So guys, first we need to understand the reinforcement learning. Guys, this is my agent and this is my environment. Reinforcement learning is concerned where the agent is going to learn by himself, right? So let's imagine this is an environment. Just forget this 110. So this is an environment and this is your finish line, and this is where our agent needs to finish up with. These are the places that are not allowed, right? So if the agent lands into these places, like it's like a fault. So now I leave my agent to learn in this environment, and first step what my agent is going to do is my agent will start learning, right? So this is the path 1 and it says the path 1. So path 1 did not give us the right result, so hence we can say that path 1 is 0, right? So reinforcement learning is very simple. If the step is correct, you get a 0, you get a 1. If the path is incorrect, you get 0, right? Okay. Now another path, again a 0. So this is path 2. So again this path 2 is not returning the correct result, so it won't get the reward, right? Let's go with the path 3. Again it failed, so again the path 3 is 0. So this is how this agent is going to experiment with this environment, and it is going to get 0 or 1. It is going to get reward or it is going to get the penalty. So if it is the reward, so it is going to know that this is the correct path. If it is a penalty, it is going to know that it is the wrong path. Now let's imagine it is able to find out the right path. Again the path 4 is wrong. So and now it is able to find out the right path, and that too in 8 steps. Now guys, this one is the right path and this is the 8 steps. So there is 1. So the agent has been rewarded with 1. Next there is another path, that is path 6, and again it is of 8 steps, right? And then there is another path, that is path 7. Again it is having 8 steps. So these are the right paths. So basically why I have written down the steps here, so that later on when the agent wants to find out that which is the most optimal path here, it can easily find it out. For an example, there is some path, there is some shortest path, so it can easily find out the shortest path. So guys, this is very simple example of reinforcement learning. This is how self-driving cars learn, right? and we leave them in an environment and they are going to learn by themselves. And then once they have learned, once they have gone through all the important use cases, they can actually, the model gets trained. So guys, the next thing that we need to take is supervised learning. Guys, supervised learning under supervision, right? So the problem where we already have a data set, right? And we have the proper data set with labels. Just remember, we have a proper data set with labels. That is known as supervised learning. Means it has a predefined labels. Let's take an ideal example of spam messages, right? Now for an example, I have a data set and my data set has two kinds of messages. It has spam and it has ham. Ham are the good messages and spam are the bad messages. Guys, so I have a label of all of them. A quick look of those labels can be seen here. So this is my Excel file where you can see I have the dataset ready of spam and ham. I'll share this Excel file in the Google Docs and you can find it in the description box. Okay, let's move forward. Now guys, next is, so we based on this data set, we are going to train our algorithm, right? Now the problem statement is that we want to differentiate if a message is a spam or ham based on the data set that we have been given. Now there are various algorithms to do so. However, I'm not going to dig into algorithms right now, but I'm just making you visualize that. Imagine there is some algorithm, right? Okay, so now actually what this algorithm does is, this algorithm is actually nothing but it is a formula that converts the text into numbers, right guys? Because the computer system does not understand text, it just understands number. So I have just written the example of two algorithms right here. TF, IDF and word to vec are two algorithms that actually convert the text to numbers, right? And this is an example, right? For an example, 2018 champions Chennai ground final, IPL Kings return super the one. So this is just an example of how the text is converted into numbers, right? Quite easy. And then guys, this, once we have these numbers, next we are going to plot them on a graph. Like for an example, this is one of the classification method. So we will have x-axis and y-axis. So let's imagine that we know that the after converting into numbers, now we can actually get the category that these are the numbers in which we get spam and these are the numbers in which we get ham. So just imagine these red blocks are your spam messages and these greens one are your ham messages. And this is the new message that you need to find it out, that if it is a spam or a ham, right? Now guys, you have the number systems, right, of the ham messages and you have the number of your spam messages. This graph is just to get you the visualization. And guys, if you just plot a small division boundary between the two, you see the spam are actually gathered at one place and ham are actually gathered at the other place. Now if you have to guess that this new message in yellow falls into which category, you can actually easily guess it. So guys, what we are trying to do here, we are trying to classify, right? Hence this is supervised learning with classification. I hope you find that very much easy. right? So this is actually classification. So guys, let's next talk about regression. We just studied about classification, right? So in classification, it provides us with a value, or it provides us with a result that falls into either of the two categories. In our case, it was SPAM and HAM, right? But however, in regression, like, we try to predict the result by observing the relation between two or more than two variables. So what I mean is, for instance, here in this example, I have taken years of experience and salary. So obviously your salary increases with number of years of experience, right? So as we will get the data set, right? So we have a data set. Now based on that data set, what I'm going to do is I'm just going to plot this kind of graph. So I get the relationship between salary and year of experience, right? And I actually get the equation of this line also, right? I have the, now this is the data that I have. Next, actually I can predict further. So this is my prediction, right? This is the red line is my actually training, and the next black line is my prediction. So now, for an example, for let's say 21 years, the tentative salary I have written here, which was not present in our data set. So here I am trying to observe the relationship between salary and year of experience, and I'm trying to the future. I'm trying to get the future value. Guys, this is just two variables. I can have multiple variables also. So this is just to explain you what regression is. However, when I'm going to discuss the linear regression completely in detail, there are many flavors of regression that we will be seeing, and with all the practical data sets and with all the practical examples. Next, we advance towards unsupervised learning. Guys, the regression and classification were the two types of supervised learning. Now we have unsupervised learning. What is the difference? Like I have already told you that in unsupervised learning, we just have data. We have no labels like SPAM and HAM. We have no labels. Now, basically, using the clustering method or the clustering algorithm, we are going to find the patterns in the data, right? So we will just find the clusters, or we'll find that, okay, these are the ones that have same pattern, and these are the ones that have same pattern, and these are the ones that again have same pattern. Let me elaborate this point with a further example. Let's say we have some group of people, and these group of people like ice cream, like everyone, right? So now some people, now we have the data that which people or which individual likes which kind of flavor, right? So there are some people who like strawberry, who like vanilla, who like chocolate, right? Now using our clustering method, we can actually group them together, right? We can group, if you see, so I have just grouped them using the color, and here are my color notations. So you can group them together. Now based on this, actually, if you want to find out the demand for which of the ice cream flavor is more, or which of the flavor of ice cream you need to order into your shop. This is just a very simple example just to explain you. However, the real life problems are not that simple. So what I mean is, using our algorithm based on various parameters, this is just a very simple parameter, based on various parameters, it can actually perform the clusters. So guys, we have been discussing about the algorithm or the model, what we better call. So what is actually that model, right? That performs our regression, that performs our classification, right? and that performs supervised, unsupervised, or different kinds of learning. What is actually that model? So let's define it. So it is actually a mathematical model. It is actually finding the pattern. It is identifying the pattern, right? The pattern of the data from the data sets. And this is what is actually called the learning, right? So once it identifies there are various ways to identify those pattern, and this is what we call actually different algorithms. Now, once the pattern is actually fine, it is a fit, we call it a fit. And so now once our pattern is fit, so we call it as a perfect model, right, for us. For an example, if our model is predicting the SPAM and HAM to a good amount of accuracy, it cannot be 100% accurate, to a good amount of accuracy, right, we can actually call it a fit. However, there are different terms of overfit and underfit. I'm not going to discuss it here because this will unnecessarily confuse you. But all my aim is to define what a model is, right? I just want to keep this first one very simple. Guys, let's summarize this. So supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, that has data sets with labels, right? Unsupervised learning, it actually uses clusters, right? Processes grouping of data into similar categories. And reinforcement learning, where an agent learns the environment and hence it is rewarded with 1 and negative is rewarded with a 0. Hence it develops its learning. Guys, please share and subscribe because it takes a lot of effort from my side to come up with this kind of visualization. And I want you to leave your questions and feedback in the comments. Thank you so much.